Hi everyone. In this video, I will explain about the thermal physics, and specifically, it's about temperature, what is temperature, and thermal expansion. So, yes, I know that we use this word a lot in our life: temperature, the temperature of our body, temperature of the surface, the temperature of the room. But what is temperature? um, what is the difference between object that has different temperature? For example, I have two metal cube. Let's say this one is 30 degrees Celsius and this one is 100 degrees Celsius. It's metal, so it's not melt yet. So if we see this metal, they have different temperature. We cannot see the difference. They look the same. Only if we touch it, this one will appear more hot to our skin. But what's the difference inside of this metal that can make that we can measure using thermometer that they have a difference in temperature? Basically, it's very simple. Temperature is the measurement of the movement of particle. So inside of this metal block, metal cube, there is a metal particle, right? Metal atom, metal molecules, this metal atom, yeah, for example, metal atom. And they are always moving, they are constantly moving. We know this as Brownian motion. They're moving randomously and continuously, they're always moving, and the speed of this particle move is determined by the temperature and the vice versa. So if you can make this particle move faster, the temperature of this cube will be higher. Or if you make this temperature higher, it means you make the particle move faster. So that's different between object with different temperature, the movement in particle. So what is temperature actually? In physics, it is the movement, the measurement of particle movement. And then if we increase temperature, it can make the shape change, it can melt, it can change state, and it can expand. So in this video, we'll explain about, let's not start with the formula. Let's start with the logic. If you expand an object, there are several things that will affect how much, how far the object will change. Of course, it will depend on how much you heat the object, the change of temperature, how much you change the temperature of that object. Makes sense, right? If you give more heat, you increase the temperature more, of course the object will expand more. The other things is the material. If you heat glass and you compare it with, let's say, iron or steel, of course the glass will expand less because different material will expand differently. So material will affect the expansion of your object. And the last one is the size, the original size. If you have object with same material, let's say like this, but let's say the other object is like 2 times longer, like this, so they have, this is same material and this is 2 times, like around 2 times longer than the first one. And if you expand both at the same change of temperature, for example, I put the red one for the expansion. So let's say the first object expand this much, the red one is the expansion. It means the second object, if I, let's say I can split it like this, of course the first object will expand like half, will get this much expansion because they have same material and they have same increase of temperature. Of course the expansion will be the same. So the first half will expand this much and the other half will also expand this much, right? So the total expansion of the second object, the longer one, will be twice compared with the shorter object. So the original size will affect the expansion. The longer or the bigger the size of the object, it will expand more. That's why um, thermal expansion affect a lot in construction like big building or long railways because that object because they use a huge or very long object, and when it expand it will expand a lot. And three factor this factor, the one that will affect the expansion, is being translated into a formula. Basically this is the same thing. The expansion or the change in length, the triangle here means the change in length or the expansion is affected by the material. This is material or the CTE, coefficient of thermal expansion. The symbol is CTE, or you can use the alpha here, alpha. And then the length, or to be more precise, I put LO, or original length, or the original line, the original size, and change of temperature. This is change of temperature. So the formula basically just translating the concept here. So I want you to not just remember the formula but also understand why this formula could become like this. Because this is the most make sense things, right? The change of length or the expansion will be affected by the material, the original size, and how much you heat the object, change in temperature. Okay, for the calculation I will not explain much because you only need to put this into the formula, put the CTE times with the original line times with the change of temperature, and you will get the change in length. I will move into the application. Well, the application is the most common is to open the jar, right? To open the jar that is close to tight. You can put the hot water in the metal lid because it will make the lid expand. And as you can see, this is made of metal, so the metal will expand more than the glass. So even the glass still um, get uh, get heat from the water because maybe it gets splashed also by the hot water. But because the material is different, it means they will expand differently. The metal one, the lid, will expand more than the jar, so it will be easier for us to open the jar. The other example will be the bimetal. What is bimetal? Bimetal is, here you can see there is a blue and red metal, so it's two different metal. They have different CTE, and it means if you hit them they will expand differently. One metal will expand more than the other one. For example, in this case the red one will expand more. So in case wait. Okay, so the bimetal, this we have blue metal and red metal, and they are glued together here. They are being glued. So um, if they are not glued, if they are not stick together, when I expand this metal, the red one will expand more, and it will be like this. The metal will be like this, right? The red metal will expand more. In this case, in the simulation, the red metal will expand more because it has higher CTE. It is if this metal is not stick or glued, it will be like this. But because this metal is glued, it means the red metal cannot split like this. It will become like this. It will bend. Why it's bent? Because the blue and red metal is being glued together. So when the red metal expands more, it will make the bimetal bend. Okay, you can see this like running track. If you go to the running track, the one at the outside will has a longer distance. So in this case, the red metal is, for example, the running track. Nah, okay, something like this. For example, if you have see a running track, the one on the outside, the one that running and at the outside will have a longer distance compared with the one on the inside. And the same things like in the simulation, the red one is like the outside in the running track. It has a longer distance, so we can make a conclusion that the red one has a bigger expansion and bigger CTE. Okay, and this is connected to alarm. It will tell us that the temperature is too high. So it can also be connected to other device, for example, like air conditioner. If it's too hot in the room, it will turn on the AC. Or it can also connected to oven, for example. If it's too hot, it will turn off the oven, so we can get the food at the temperature that we want. If it's too hot, it will connect it to the electric circuit that will cut off the electricity. So it means we can use this thermal expansion concept in bimetal to create an automatic switch. We can turn on or turn off electronic device using the temperature without we need to turn on or off manually using our hand. It can turn on or off automatically by measuring the temperature of the room or the surface or the food. So that's the application of thermal expansion. Thank you for listening.